good information. While everyone logs in, I'll just cover a bit of ground. We're International Cement Review. We published every month. And if you haven't looked at the magazine or the website before, do check out cemtech.com. All the content and information that we explore in these webinars is also explored in the magazine, as well as other industry news, market analysis, and points of discussion. So get your copy if you haven't already got one. All subscribers will get a copy of the Cement Plant Operations Handbook. That's our concise guide to manufacturing technology, indispensable, especially if if you operate out of a plant and you need a handy reference. Do take a look at that, or select the Cement Plant Environmental Handbook, which is a fantastic compendium of around 40 articles covering all sorts of things, many of the topics we're discussing today. Coming up next month, we have our annual cemtech Europe conference. Great interest in this. We'll be in Istanbul, fantastic city, with the support of Turk Cimento, the local cement manufacturing association. And there's a really fantastic lineup of speakers. Go over to their website and you can download the program, see who's speaking. If you can attend, then I highly recommend it. It will be a great couple of days out in Turkey. But today we'll be talking about solutions to decarbonize cement production. We'll be exploring opportunities to reduce CO2 through process optimization, deployment of advanced supply chain and logistics, clinker reduction, and carbon capture. So looking at lots of different technologies. It's a wide open subject, but one that's now so central to all that we do in the cement industry. As we move on, I'll just draw your attention to the chat. Please tell us where you're from and what you're interested in, and communicate there. But if you want to ask any questions, look for the Q&A button on your Zoom interface, and you'll be able to type in questions for each of the speakers today. And we'll try and get through those after their respective presentations. So what have we got today? Well, 4 excellent companies covering all the different areas that I mentioned earlier. Sumitomo from Finland. We'll be talking about carbon capture. We've got Chryso GCP, talking about cement additives, performance additives, and how to produce low carbon cements. Inform, experts in AI and digitalization of the logistics process. Again, another very important aspect of reducing carbon, which is maybe not so obvious to people who are focused more on the manufacturing. But to start with, I'd like to welcome Pedro Ladera from FCT Combustion. He's going to talk to us about the reduction of CO2 through process optimization. I'm going to let you share your slides now, Pedro, while I give your introduction. I can see the first slide already. That's great. Pedro is Technical Director at FCT Combustion with over 25 years experience in the cement, industrial minerals, lime and fertilizer industries. He's held both managerial and technical positions across Latin America with a degree in chemical engineering. He's also a master's in NOx emissions reduction in clinker kilns, holds a number of patents, and has developed novel processing routes for a KTO-based fertilizer. Pedro is an experienced pyroprocess technician, currently focusing on sustainability projects, engineering, R&D, product development, and optimization. So really highly qualified for this presentation. It's great to have you back, Pedro, for this presentation. Over to you.
Thanks, Thomas. It's always good to be here. Well, I'm going to jump quickly into the presentation. Just a quick overview about the company. FCT provides solutions for the cement industry. in so many different areas, from grinding to calcining to drying, burners and burner management systems. And also we are putting a lot of focus on the calcium clay business. We serve not only cement or iron ore, we go into lime, pulp, paper, mining, and other mineral industries. And the good thing about this is we can use technologies from one industry to the others, and we can really gather a lot of information and learning from each of them. Well, so we are in very different places, from clay calcination to the cement kiln burners and hot gas generators and so on. It's like in pelletization of iron ore, for example. Different clients, we have all sorts of clients from different origins. And we are spread all over the world. We have offices in Adelaide, in Nanjing, in Vienna, in Brazil, in Sao Paulo, and Fort Lauderdale in the US. So you can pretty much reach us in any part of the world. And the topic here is the reduction of CO2 footprint in the cement industry through process optimization. I was thinking how to introduce the topic, and I would say, well, probably the easiest way to say is that process optimization is equal CO2 reduction. If you do things properly, if you reduce consumption, if you raise the efficiency of a cement mill separator or a grinding media, or anything that is related to that, you're certainly going to go and reduce CO2. But although it's quite a generic statement, I will just go into ask for some help from the roadmap to carbon neutrality from the Portland Cement Association in the US. And they have split this into 3 sections, one being at the cement plant with different topics and areas of opportunity for increasing efficiency and reducing CO2 emissions. And then you go into the construction, designing and building, and then you go into the concrete infrastructure already in use. So all these 3 could cover different opportunities for CO2 reduction, but let us focus for a while on the first one, which is at the cement plant. So the pathway for carbon neutrality goes along with the use of alternative fuels, continuous efficiency improvement, carbon capture, clinker improvement, and promotion of SCM and PCL. So first we start with alternative fuels. I just put here a picture where we can see the heat value of all fuels is really going down, and the majority of it being based on less traditional fuels and more alternative fuel, different sorts of alternative fuels, and the challenge that's posed to us those days of using all sorts of materials in the fabrication. So sometimes when you do that, the first thing you notice is that you start building rings or balls or weird things going inside the kiln due to a poor combustion and circulation phenomena, a lot of sulfur flying over, and then condensation and so on. And this can be a disaster from the health and safety, but also from the performance of the main pieces of equipment like the kiln and the heat consumption and so on, and loss in productivity and production and sales. So that can be quite a bit of a challenge. And the way to tackle that, I can give you a summary being, you have to promote early ignition. So if you have a main flame, the main burner, you might be able to quickly start the ignition in the first meter or even less than a meter from the burner tip, even using difficult to burn fuels like alternative fuels. So what we are looking for here is how to get to this early ignition. One would be, well, looking at the design of the burner. The traditional burner goes with an axial air and then solid fuels and through air. And you can give it a different configuration. As you can see here, axial air has a different pattern of distribution and area, but total area of air is the same, and you can do it in 3 different ways, from grouping them with big holes or small holes, all well distributed, and it will influence the shape of the flame and how early you can start ignition. So This is for the same area, the same impulsion or momentum of the burner, but if you arrange it differently, you might have different results. So one being the 36 even, we made a simulation showing how does the heat flow distributes along the kiln. And it's kind of concentrated here, but if you just change it for this configuration, bigger holes, and at least less number of holes, but with bigger area, double as much. So this will give you a higher peak of radiation and more heat transfer, more concentration, which means a more robust flame. And if you go in then with the same number of holes, and then but now they're grouped together, and then you might experience even higher peak, which means you have a more robust and compact flame, more prone for a higher quality clinker. So what we've been doing based on that is trying to use both configuration altogether, trying to use this concept whenever it's not necessary to have such a very concentrated flame. And then if you want to do this, we put together this in one single equipment, which turns out that we can run it with air through the small holes or without air in the small holes. So depending on how much you want to shape the flame closer to the burner, depending on the amount of alternative fuels, you might need this flame. If you're not running so high alternative fuels, you might use this one instead. So one compensates for the poor ignition and the other one does not. So in the end, you get the same flame in different configurations and different amounts of alternative fuel being used. So when you look at this, the burner looks like this. As you can see here, most of the secondary area is going to be entering through this area here. Whenever you keep this low, it's going to be even more secondary air. And when you see it from the back, the burn gets a bit more complex in terms of configuration, but you give you more flexibility to really format the flame, they shape it the way you want it. The other thing you can do whenever you were spraying or you're injecting alternative fuels, you can give it a bit of a swirl. By swirling it a bit more, the dispersion of alternative fuel will allow you to burn even earlier than if it was not dispersed. So by swirling the injection point, you're probably going to be able to have a much robust flame, meaning that you're going to have less problem with sulfur recirculation, to name one. So you can do this with a brand new one, but you can use an existing burners. As you can see here, this is originally was a burner from the competition, and then we wanted to change part of it. So we tapped a bit some of the holes you have here, and then you promote this higher entrainment in secondary air while changing here the configuration of the swirl to promote even more mixing and a better flame. So this was a very successful project, very cheap to be installed, and finally they got the result they wanted just by changing some principles or the geometry in the burner tip. So again, it's all about early ignition, as you can see here, and as a result of those blind points here where the secondary air enters, here you can see here kind of stripes, where here you have all the secondary air coming in, and then you have a very early ignition, so we promote this very good combustion. Basically what we do, we made it to measure. So what we do, we shape the flame, we shape the burner according to the client's needs, the types of fuels and amounts and so on. So you're going to have your own burner for your application. The second topic would be continuous efficiency improvement. On this one, I really reminds me of my time when I worked for the cement company, where I used to be a process engineer, and I have this feeling that everything goes along with the process engineer, and the process engineer is that guy that is continuously measuring, for example, the granulometry of the clinker. So depending on the granulometry, you can recover more or less secondary air. More secondary air means that you have a lower heat consumption, less loss in heat through product, and then you can really recuperate heat. So it all depends on the granulometry, which by itself depends on the coating conditions, the clinker moduly, and the burnability of the material. So one of the most important things is to know the chemistry. When you know the chemistry, you can attain this granulometry, recover more heat, have a more stable kiln, a more stable coating, and a longer campaign. So all because you're really managing the chemistry. And as a result, of course, you might reduce CO2 emissions because you're running at improved heat consumption. The other thing you can do, you can have a look at your calciner and see if you're injecting fuel only on one side, and you put together a CFD model, and you see that as something that we do also, and you see that the fuel distribution is uneven, so you have high oxygen, low oxygen, poor combustion, and you can have an even distribution of fuels by injecting 2 different points or 3, 4 different points. You can get better results, earlier heat exchange, and then lower temperatures on the preheated exit, which means lower heat consumption, by which in turn means a reduction in CO2 emissions. And then you have all sorts of possible distribution and patterns, and the way you regulate flows and how you swirl the flows to get a good and proper combustion. Also, as a result of a good flame and a good burning early ignition, you might have a short flame. By short flame, you mean in the end you have smaller halides, and by having smaller halides, you're going to probably have better efficiency and better concrete properties, and you can use even less clinker and substitute with other cementitious material, and then you reduce CO2. And also in the burnability, it's the same. When you put together the right configuration of the chemical modeling, you might be able to really improve the burnability, and by improving burnability, you reduce the temperature where the material is being processed, and then you again reduce heat consumption. When you know what you're doing and you balance all the elements entering the kiln, you can really get to an equilibrium between sulfur and alkali, and by that you can reduce the sulfur cycles, and then you can prevent the formation of rings and all this difficulty you may have in the process. And also you can prevent yourself from clogging the preheater and really control the internal cycles of those nasty elements that used to have in the cement industry, in the clinker kiln. So the other two would be carbon capture, something that we are not addressing in this presentation, and clinker improvement. We sort of talked a bit about this, but we go straight to the promotion of LCM. LCM being that we are starting from the traditional Portland cement, 95%, 5% gypsum, and the opportunity of not having CO2 is only on the 5%. All the other one is CO2 intensive, coming from the decomposition of carbonates, but also from the combustion of fuel. So there's a lot of CO2 involved in this portion here. We cannot really say no CO2 because there's a minor amount of CO2 being emitted for the fact that you are bringing in gypsum and you are mining it and so on. But again, you can use all sorts of substitute elements for the composition of cement, and if you do that, you can go from this configuration through something like 50% clinker, calcined clay, limestone, and gypsum. So here you really are relatively low to no CO2. Again, this one has less CO2 because it doesn't have the carbonation taking place. So all the CO2 will be reported as a fuel CO2 for this one, and the one coming originally from clinker. So you reduce the total amount of CO2. So when we go into looking at this calcined clay, that can be a big chunk of the reduction. We look into synthetic pozzolans. Hopefully, I wish we had natural pozzolans all over the place, but we do not have it. So we get material when we heat treat it, the clays, and fortunately, the temperature they need for the dehydroxylation ranges from 600 to 900, which is relatively low, and you can produce nice metakaolin out of it. So instead of producing C2S, C3S, we are producing AS2, a good substitute, which has low to no CO2 coming from the raw material. Now, what we typically do, we map the material, we see where it loses moisture, when we activate the clay, and where it starts to crystallize. We'd like to have material that is pretty much amorphous. We don't like it to be crystallized, so we should reach a temperature where all the activation takes place, but then we stop it in a certain temperature to prevent the material to crystallize from crystallizing. Well, FPT has two technologies for clay activation, one being the flash calciner and the other one being the rotary kiln. We don't prefer one over the other. We just look in case by case which one is the best fit for your process. Different configurations, you can run the preheater or the flash calciner with a hot gas generator, and then you have a dryer. You have to dry the clay before entering the tower. So finally, we can use very flexible combustion systems like hot gas generators, and you can introduce a lot of biomass, alternative fuels, and even coarse fuels. So what we know, it's always the first question whenever you're talking about clay, what about the color? Clays can have different colors originally. After they are activated, they can become red, or the cement can become pink. We know this pinkness, there's no correlation with cement performance, although the market acceptance for pink cement or red hue cement is really limited. So we must try and control the hematite and try to get as much magnetite and prevent it from being the ion being reported in this more oxidized form. So different ways of doing that, but basically what is being done lately is to control the atmosphere inside the kiln and during the cooling. One of the first of the traditional methods is to promote a reducing condition. You reduce the oxygen available to oxidize magnetite, or you keep the oxygen low. It can be fuel in the feed, or it can be fuel in the kiln discharge. The good thing about using those methods here is that it's relatively low in capex, but the cons is that probably all the fuel you're putting in the feed, it's going to be lost. So you increase the overall heat consumption. You might be also facing an increase in VOC and CO emissions. So good, but it's cheap to be installed, but probably you're going to pay an important fee for running with this configuration. If we go for quenching instead of we try and keep the ion as magnetite, which is the form of ion that only occurs at higher temperature. When you come down with the temperature, it becomes hematite again, and we try to freeze it as magnetite just by quenching. You might use water spray in the kiln discharge, or you can use indirect cooling. That might be, depending on the configuration, low capex. I leave a question mark here because normally indirect cooling is not the cheapest option. So, but either way, you will increase heat consumption, electrical consumption by you applying this methodology. And there is a patent development from FCT. We call it the inorganic modifiers. Basically, what we do, we're trying to source in your quarry elements that could immobilize the magnetite. So if we can bind the hematite, the magnetite, with something and preventing it from becoming hematite, we can probably control color. So the action is to determine the most suitable reactant to bind with magnetite and preventing it from becoming hematite again. And what we see as one of the most important pros is that you normally have an improvement in the concrete properties one of which is you reduce blame. By reducing blame, you know that the water demand it's going to be lower, so the demand for plasticizer reduces and so on. What is cons? Well, we cannot say it. It's a case-by-case evaluation. But generally speaking, in terms of CO2 footprint compared with the other methods, we're better off in this one. So we can provide you with pilot plants. We have a flash calcination in Brazil. It's a flash calciner mounted in 2 containers. It operates. We've been doing a lot on this for scale up and to provide solutions for our clients. It's basically a hot gas generator, a calciner loop, and then we quench the material with air and get product from it. And we also have a rotary kiln calcination. It's a sizable pilot plant. We have also, so we can submit your product for testing in our facility, so we can have the proof and the collect data needed for the scale up. This is when you do muffle calcination in an oxidizing way, and in different temperatures. But when you flash it in high temperature with the right inorganic modifier, you can have a pretty dark product. So the same happens from when you get the ore and you muffle calcine it, it gets red. When you flash calcine, you can get the material with less of this red hue. This is a quick video showing the utilization of inorganic modifiers. You simply mix the inorganic modifiers along with the feed, and you can see here the material is not even ground. It's just volumetrically added to the feed. It's being processed in the rotary kiln at very high temperatures. And this one is it's fired with diesel, high oxygen content in the kiln atmosphere, so there's no oxygen control or any depletion of oxygen here. But as you can see here, the product becomes gray because of this interaction of the reaction between the inorganic modifier and the clay. So we succeeded on doing the right color control. This one was a very, very high content ion, over say 15% of iron oxide in the raw material, and we managed to get the gray color despite oxidizing conditions in the kiln and not using water, not using any special fuel to do that. And the product become like this, and when we get from the original clay into the calcine clay and the cement afterwards, you can see here very low A numbers, each one of them that we use to measure color in terms of red. So pretty much what I was trying to say is that there are different methods of reducing emissions of CO2, but bear in mind that you have to keep yourself technical and very skillful process engineering team in your plant. You have to have the right burner, not only with a high impulse, but also a high impulse and the right configuration of the air so we can form it and shape the flame. And you can use novel technologies to control color with a good, reasonable footprint and get the results you need. So basically what I tried to cover on this one was those aspects of alternative fuels, continuous efficiency improvement, and the promotion of substitutions for the cement industry. So, well, thanks a lot for your time, your patience, and I'll be for any questions.
Thank you very much, Pedro. That was a great overview of the classic decarbonisation technologies. Starting with the pyro process and the burner design and fluid dynamics being used to improve performance. Just a general question about the burners. If a plant is transitioning from, say, 5% alternative fuels to 25%, is one burner enough to cover that scope? Or do you need different burners when you're moving to quite different levels of alternative fuel utilization?
Depends on what you already have as a hardware. If it's a relatively new burner with a good configuration, you can just tweak it to some extent. You can probably change from a fan to a blower and get a different configuration, and you're ready to go. Sometimes you need to add injection pipe and may not fit into the burner body. You might have to put a satellite burner or put something on top of the burner, or you can completely reconfigure your system. So it will depend. But yes, normally the message here is it may be possible to reutilize whatever you have and just tweak it. But sometimes just it doesn't pay the price, so you probably have to completely change it.
Mm-hmm. Okay. A question here on the burner: how much fuel consumption can be reduced using one of the burners? So in terms of kilocal per kg of clinker.
So if you were affected by the inlet temperature of the kiln, where you have a very lazy flame, and then you're losing through the exhaust gases some of the heat, it might be impressive. In some cases, might be minor. But normally, the overall reduction is not only on the heat consumption, but when you get the right crystals, the right halide crystals in clinker, you might even save on grinding as well. So it will go case by case again, but it can be very, very beneficial for different reasons, including grinding. And of course, if you have a more concentrated flame, you might be able to produce higher quality and utilize more substitution of clinker as well. So many benefits. It's difficult to tell one. It's more case by case.
Okay. Quite a few questions about calcined clay. A lot of interest in that. You highlighted the two systems, flash calcine and rotary kiln. It's clear that the rotary kiln, these can also be conversions of existing kilns. I was just wondering, can you convert an existing preheater into a flash calciner, or is that not something that's been tried?
We made this exercise, but normally the flash calciner has one zone that's for preheating, the other one for calcination, the other one for cooling. So it's hard to fit all these three zones in an existing plant. So normally it's better to make a more compact and made to suit instead of reutilizing the preheater. You might be using the building as a support, but probably not the preheater itself.
Okay. And in terms of the actual process, question here, when using reducing conditions to manage the clay color, does that affect the cement performance?
Yeah, indeed. You might have problems like, for example, you have a long flame as a consequence of this reducing condition. You delay the combustion. You might have problems with that. And yes, in many ways you can have trouble with that.
And also calcined clays normally have higher water demand. How does that affect the concrete or cement strength?
Yeah, a lot. I mean, a lot of just water demand means that you're going to add and lose strength of the concrete. So you may manage this by plasticizers. So you pretty much substitute part of the water. And the other thing you can do, you can provoke to some extent some sintering, some reduction in the blend, and then you can succeed in having the right blend for it. So you can compensate for that.
Okay, so you can compensate for those weaknesses.
Correct.
Yeah. Okay. Well, thank you very much, Pedro. There are a few more questions if you want to have a look in the Q&A, but we better move on now to our next speaker. But thank you very much for that presentation.
My pleasure. Thank you.
Very good. Next, we have Carsten Horn from Inform. And that's very quick. The presentation's up there. You can see cost and carbon reduction in cement supply chains. As a senior manager for business development at Inform's logistics division, Carsten has nearly 25 years experience in IT and logistics. Based in Germany, he serves clients around the globe and has found a unique way for cement and ready-mix concrete producers to embark on the road to AI and net zero in logistics. He's also co-host of Inform's webinar series, Logistic Tech Shorts, with his supply chain expertise frequently being sought by industry media and associations seeking to provide a blend of big picture thinking with practical ideas. So lots of interesting ideas in this presentation. I'm going to hand it over to you. Welcome, Carsten.
Thanks, Thomas. Well, CO2 reduction in the building materials industry, usually focuses on production processes of these materials, be it cement or concrete. Logistics and transport, however, they are also a relevant source of greenhouse gases and responsible for a lot of air pollution. But compared to the production processes, CO2 reductions in logistics are what I call a low-hanging fruit that allows cement producers to improve their overall carbon footprint. For those of you who already listened to one of my presentations, they know that I would like to take you on another road trip. And this time on a road trip to cost and carbon reduction in cement supply chains. Okay, so you ready? Let's jump onto the truck, buckle up, and off we go. All right. Finding the shortest route to your destination, that is quite an easy exercise nowadays, because we all have route planners in our pockets or sat-nav systems in our cars and trucks. But route optimization in building materials logistics is not only about finding the shortest route from A to B. Route optimization is about making better decisions in terms of truck order allocation. Things are different and way more complicated when you have a fleet of vehicles and each vehicle has to make several deliveries each day. So here's quite a simple example. Let's assume you have 4 plants, 2 trucks, and 4 orders. So what order truck assignment and route combination will offer the lowest empty mileage? And why empty mileage? Because the empty trips back to a cement plant, they have the negative impact on the carbon footprint of your fleet. So reducing empty mileage is an important element in CO2 reduction. We humans, we are creatures of routine. And when we establish routines, we can carry out tasks a lot faster since we simply don't have to think about the task or prepare for it. So routines allow us to go on autopilot and still accomplish most of your objectives. And our brain likes to run on autopilot because having to think about every little decision, that requires a lot of extra energy. And this is why we create patterns in our brain that we can quite easily follow. So in this case, choosing the closest follow-up job promises to be a pretty good routine that will deliver quick results. Here, 72 miles. But if you sit down and take the time to calculate through all possible options, you will find a solution that offers substantially better results. Here in this case, for example, 31 miles instead of 72 miles of empty traveling. And that's a reduction of 56%. 2 trucks, 4 plants, 4 orders. You might say, this is an easy exercise. And you're right. But imagine you would have to do this for a fleet of, let's say, 100 trucks and 300 orders. So how much savings could you achieve both cost and carbon-wise? Speaking about CO2 emissions, I would like to give you a flavor of what a typical cement bulk truck emits daily and compare that to the production of cement. Currently, for every ton of CEM2 cement, something like 550 kilograms of CO2 are emitted. And the targets of the major cement producers are to bring that down, or at least close to 400 kilograms by the end of this decade. But if you hit the road with a full bulk tanker and do 2 round trips of, let's say, 190 miles each, the exhaust pipe of your truck will have blown out the same amount of carbon at the end of the day. So we're talking about 564 kilograms. So what's your target here to bring this down by 2030? Are there any targets? Okay, maybe the comparison isn't fair because on the left we have 1 ton produced and on the right 56 tons shipped. But if you look at the overall transport volume of the building materials industry, the logistics of our sector has quite a big footprint compared to other industries. Because in many countries, 25% of the total road transport volume are construction related, be it cement, aggregates, ready-mix, stones, bricks, gypsum, and much more. And that is simply too big to ignore. Before we move on, I would like to share a bit more about Inform and what we do. So we're a German-based company and we build software that is powered by algorithms and helping our clients to make better decisions via a digital decision-making process. And we do this with the help and expertise of more than 950 employees for more than 1,000 clients all around the world in a variety of industries. For instance, logistics, but also aviation, production scheduling, warehousing, workforce planning, inventory and supply chain, or finished vehicle logistics. And we have offices in North and South America, Australia, and in Singapore. And we have been supplying solutions to the building materials industry for many, many years now. And we are quite fortunate to have some of the big and medium-sized players to put their trust in us. Meanwhile, 30 years ago, Redlands in France, which is now part of the Holcim Group, that was the first company in the aggregates and ready-mix industry to use our solution. And in 2001, Hanson Australia, which is now part of Heidelberg Materials, they integrated our software into their supply chain. And Hong Kong-based construction companies like KWA and Alliance, they followed later. They all have been using algorithms, real-time information, and automated decision-making to manage and optimize their fleet of trucks ever since with really amazing results. So, how do we lower our footprint? Well, as a first step, let's take a look at the certification system of the Concrete Sustainability Council for guidance on the road to net zero. Well, yes, I know it's concrete, but the certification system also includes the performance of cement and aggregate supply chains. So it's worth and relevant to take a look at. Industry partners from Europe, USA, Latin America, and Asia, they initiated the development of a global responsibility or responsible sourcing certification system, which was designed to help manufacturers comply with industry and consumer demands for responsibly sourced concrete products. So the maximum points you can score are 179 for concrete, 240 for cement, and 172 for aggregates. And producers, they can score points in the following categories: management, environmental, social, and economics. And there are 9 items listed under environmental, and number 8 is transport. So let's zoom in there and break this down. The maximum points you can achieve for transport are 5 points, and you can get two extra points. I come to that later. So you'll get 2 points if your organization has a transport policy in place that addresses the environmental impacts of your transports. Well, fair enough. You'll get 1 point for providing fuel-saving awareness training to your own, but also to your external drivers. That's fair enough too. You may get 2 extra points if you have at least 1 next-generation truck in operation. Well, again, nothing wrong with next-gen trucks, but what impact has 1 zero-emission truck on your overall performance if you have, let's say, 100 trucks out on the road? And is this really worth 2 extra points? And now comes the interesting part. You'll get 2 points if you have a dispatching system in place that contains transportation data in terms of modes of transportation and distances covered. Well, nothing wrong with having a dispatching system in place. I mean, this should be industry standard today anyway. But why a system that just contains transportation data? And why not a system that uses transportation data? A system that uses transportation data in a smart way to improve the efficiency of your logistics. Because this can mean a big difference, as we will see later in my presentation. Okay, so let's take a closer look at new-gen trucks and dispatching systems. Today, diesel is still king on the road. There's no doubt about it. But recent advances in technology and changes in legislation, they are creating market conditions that are increasingly favorable for electrification. And when it comes to trucks, the boldest move definitely happened in California, because by 2045, every new truck sold in California will have to be zero emission. So manufacturers of medium-duty and heavy-duty commercial trucks, they will begin selling zero-emission versions in 2024, resulting in 15% of the trucks on the road being electric by 2035. So how is our industry progressing when it comes to electrification? Well, my number one source for information about the cement industry, that's always the Cemtech website. And there was listed that, for instance, Holcim, they made a big splash in May when they announced that they will deploy up to 1,000 Volvo electric trucks by 2030. And the delivery of the first truck will be end of this year. Cemex is trialing an industry-first discharge system for cement, which can be fully powered by electricity to reduce fuel use and subsequent emissions. And the trial has demonstrated a potential of saving over 4,000 kilograms of CO2 in a year per vehicle when it uses the system, as well as around 1,500 liters of fuel. Cement Australia has made its first delivery in New South Wales using its new Janus GE 410 truck, which is believed to be the first fully manufactured electric Class 8 truck in Australia. And the fuel tanks, they simply have been replaced by exchangeable batteries, which provides something like 620 kilowatt hours in total, along with an electric blower discharge that works off the battery. And in India, Dalmia Bharat has launched an electric truck initiative, which will see the first 2 high-capacity electric trucks deployed out of a proposed fleet of, I think, 22 vehicles. So more and more cities, they impose access restriction for diesel trucks. Thus, it will be not so much be a question of economics, but rather a question of still being able to serve your customers. And also, noise levels, they are considerably lower compared to diesel trucks, making these EV, for instance, concrete trucks, the ideal vehicle for congested areas and city centers. Anyway, a mixed fleet of diesel and electric trucks, that will bring new challenges to your daily dispatch planning. Well, I started my presentation with route planning and how complex their calculation is. But if you add electric trucks on this equation, fleet and dispatch planning will become even more complicated. Why? Because it'll add more variables to the scheduling math. For example, range. Range is an issue with all electric vehicles. So you need to incorporate the remaining range estimate into your real-time planning. And when empty, you need to recharge. So pre-booking of available charging stations is a must. And you need to include the actual charging times into your plan. And in addition to that, the number of charging stations at each batching plan will be limited. And this will bring new challenges to your upfront strategic planning. So where do I position my EVs? And where do I position my charging stations? And you need to keep a weather eye on the horizon, because the battery performance it drops simply at cold temperatures. And on the way to your customers, the steep climbs, they will also drain your battery quickly. So the elevation profile becomes a new element in your route planning. On the road to net zero carbon emissions, cement producers and truck manufacturers, well, they still have a fair bit to go, and I think some steep climbs ahead when it comes to develop and implement new technology. And it will be quite exciting to see what can be achieved within the next coming decade. A carbon reduction strategy must, of course, take all areas and all stakeholders along your supply chain into account, because this allows you to prioritize areas where further reductions in emissions can be achieved. But when investing in new technology, please keep this simple formula for failure in mind. Old processes plus new technology equals expensive old processes. And that brings us to the biggest pothole on the road to net zero: old processes and bad planning. Because a common driving mistake that many companies make on the road to net zero is simply to underestimate the consequences that bad planning and old processes can have on their logistics performance. Because your entire fleet may be brand new and fuel efficient, and you may have electric trucks in your operation. But if you don't optimize the use of your moving assets, you will be wasting energy, money, and ultimately customer service. So understanding and optimizing your logistics processes, that should come first, and not the focus on technology only. Because otherwise, you end up doing the wrong things even faster. More than any other job, being a dispatcher, well, that brings a tremendous amount of pressure and stress, because each day is a challenge. And each decision has multiple flow-on decisions that in turn complicate the future decisions. And this is not only true for tactical scheduling, where your dispatchers determine the delivery schedule and fleet configuration for the following shift or day, but also for real-time operations. So disruptions like traffic holdups, ad hoc orders, or cancellations, well, they can affect the efficiency of your operations. And if there are no countermeasures taken, the entire plan can collapse like a house of cards, with shipments running late and costs way out of line. And what's even worse, decisions taken at that stage, well, they often ignore the environmental impact of the order truck assignment. Well, order fulfillment is more important than carbon considerations. So what tools are out there to assist your dispatchers and planners? Well, here's just a quick overview that will also give you a flavor of what these tools are capable of in terms of planning speed and quality. On the lower end, we have manual planning. Well, one would expect that pen and paper dispatchers, they are a dying species, but the truth is there are still plenty of cement producers who rely on the routine and experience of their dispatchers. One step further up, there are Excel spreadsheets. Released in the late 1980s, well, Excel, it quickly became, and some might say it still is, the reigning champion of supply chain management. And yes, the spreadsheets are easy to configure, and they allow you to analyze data or run macros to automate calculations. But hey, let's face it, they are tools of the late 80s. So please do not let nostalgia run your business. A big step forward are the bespoke dispatch and planning tools, which are tailored to the needs of our industry. But also some of them come with some sort of built-in intelligence, which are mainly predefined business rules. They do not even come close to the speed and quality that algorithms provide. So substantial gain in planning speed and quality will only come from dispatch software powered by algorithms, and that is embedded into a wider digital supply chain. Today, these algorithms, they outperform legacy systems and human planners in speed as well as in quality. And they allow transport planners to do incredibly complex and time-critical calculations with ease. And what's more, algorithms, they can take a larger range of variables into account and can process more data faster than the human mind can. Plus, it removes the human error effectively from the dispatch formula. And this in turn leads to significant efficiency increases and subsequently carbon footprint reductions across your entire fleet. And as I was mentioned earlier, electric trucks, they will add more variables to your dispatch planning. So thinking that you can manage a mixed fleet of diesel and electric trucks without algorithms, that's kind of crazy. So you gotta get prepared now. As I mentioned earlier, we at Inform, we have implemented such a software solution at many of the big players in the cement, ready-mix, aggregates, and construction material industry. And producers who have implemented our smart transport planning system, they typically achieve a reduction in empty mileage by anything between 9 to 27%, an increase of loads per truck per day by 7 to 21%, and maybe the most important thing, a logistics unit cost cut of anything between 7 and 20%. So that's quite good news for your financial and environmental performance, but there's more in for the environment. Well, with a rise in truck productivity, less trucks are eventually needed to fulfill the same order volume. And best practices in our industry have shown that fleets can be downsized by up to 14%. Or in other words, if your fleet has 100 trucks, you may easily reduce this to 86. And that's not only 14 trucks less on our road, that's also 14 drivers less to find and 14 trucks less that have to be manufactured, maintained, repaired, and scrapped at the end of their life cycle. And that brings us to the end of my presentation. So how green will you go on AI? And the best way to find this out is a like-for-like comparison between your manual or legacy transport plans and our AI-powered transport plans. And how does this work? Well, you'll give us real-world data of a recent transport plan. Maybe 3 days are sufficient, but they should be a good mix of all operational scenarios. Maybe a busy day, a typical day, and a quiet day. And data should include things like orders, available trucks, plans, and in addition, all business rules and constraints need to be communicated clearly. And once that data has been cleaned and data inconsistencies and gaps have been clarified with your logistics team, we'll feed our software with it and come up with an optimized delivery schedule and fleet configuration. And a side-by-side comparison of all optimized KPIs, that usually gives a clear indication of how green you will go on AI. So if you're interested, just scan the QR code and go to inform.com/road to SaaS. And we look forward to learning more about your logistical challenges and helping you find a smart way to overcome them. Thanks for listening.
Thank you very much, Carsten. Very interesting insights there. It's amazing that, you've talked about 25% of total industry road transport is related to building materials. If you just look at the cement industry, there's about 4 billion tons of cement a year. Aggregates is about 50 billion tons of aggregates. Yep. So it's huge. So to downsize a fleet by 14% is a really big number. But on a company level and a fleet level, question here, someone has 50 trucks in their fleet. Is that a kind of a good size fleet that you'd be able to make a big impact on with your software?
Let's say in the cement business, 50 to 70 trucks, that's usually the starting point where it really makes sense and where optimization can have that impact that I described. And the bigger the fleet gets, the bigger the impact will be.
Sure. There's a question here is, can you give an indication of the cost to implement Inform's system for a fleet of 50 trucks? And also, just in practical terms, how would it work if this company decided to take up the opportunity?
Mm-hmm. Yeah, usually it could start with what I mentioned on my last slide to do this like-for-like comparison of what's the planning look like today and what could it look like in the future. And that is also how usually the typical projects look like. So we have to talk to the customers, talk about their processes. From business point of view, that is usually also something that will then go into more detail throughout the implementation project, which also needs a couple of workshop weeks about the business processes to make sure that all the important things can be covered by the system at the end. And if that has all been done, so we have a project at first, and then there's the subscription for the licenses for the software, which is usually based on the active number of trucks that are in the optimization system, and that then is pretty much the price that, or the cost that we're talking about. It's always difficult without having more knowledge about the customers, but usually our customers, they tell us that the return on invest is 12, maybe 18 months. So the payback period is pretty short.
Okay, that's very, very helpful. So thank you very much, Carsten. If anyone wants to get in touch or have a free plan, an optimization plan, then there's your QR code, and we'll be sending the slides around for this and all the presentations after the webinar. So don't worry, you'll be able to follow up afterwards. Thank you very much, Carsten.
Thank you.
Fantastic. Well, we're going to switch it now back to cement manufacturing, and we're going to be looking at clinker reduction. And I'm delighted to be able to introduce our next two speakers, Caroline Autier and Pooja Niger from Chryso and GCP, respectively, part of the Saint-Gobain Construction Chemicals based in France and the UK. Welcome. So if you'd like to place your slides up on the screen when you're ready, and I'll just go through the introductions. So Pooja works at Saint-Gobain Construction Chemicals as a global market manager for the cement additive business. Based in the UK, she is responsible for driving innovation and growth strategies and marketing communications. Pooja has worked with the company for almost 20 years, holding several positions. She graduated from Kingston University with a BA Hons, where she studied accounting and law. And Caroline is a cement additive formulation team leader at Saint-Gobain Construction Chemicals. She's responsible for global research and development in the innovative cement additives division and manages the transfer of new technologies across Chryso GCP subsidiaries. Caroline has been in the company for 7 years. She graduated from Montpellier University in 2013 with a PhD, where she studied mesostructural scale and influence of polycarboxylate on cement paste. I hope I got that right. That's quite a PhD. So I'm really delighted to be able to introduce you both now. I think we can see the presentation slides. So over to you.
Thank you for the introduction, Tom. It's a pleasure to be here, part of this event today, and to share with everyone an update on Saint-Gobain Construction Chemicals solutions for decarbonisation. So, as Tom mentioned, both Caroline and I will be presenting today. I will just be starting by presenting some details about Saint-Gobain, CO2 reduction and the subsequent opportunities this presents for the construction industry, and some of the chemical activator solutions that we can provide. Caroline will follow with details about our new next generation activator mechanisms and supporting case studies. And we will finally look at the economical value achieved by using chemical activators. So to start, Saint-Gobain is a global company established more than 350 years ago with revenues of 51.2 billion in 2022. We are located in 76 countries and with approximately 800 manufacturing facilities around the globe. We have been recognized as one of the top 100 global innovators over the last 10 years and have also committed to carbon neutrality by 2050. Our sustainable solutions make up around 75% of the company's sales. In 2020, these solutions enabled 1.3 billion tonnes of CO2 avoidance over their lifetime. Chryso became part of the high-performance solutions for construction chemicals when they were acquired a couple of years ago, back in September 2021. Exactly 1 year later, in September 2022, the GCP acquisition was completed. As you can see from the map, it was a very complementary marriage, and we have presence in all regions and local footprint to ensure closer proximity to all of our customers. The Construction Chemicals Group consists of cement additives, concrete admixtures, and specialty building materials, and had global revenues of more than 1.1 billion in 2022. So what is the real opportunity for the construction industry with respect to decarbonisation? We have really decided to break this down into three main areas: regulatory compliance, social responsibility, and corporate or stakeholder responsibility. Starting with regulatory compliance on the left. This is largely focused on the EU for the time being and driven by the European Trading Scheme. This can further be broken down into two main parts. Firstly, the reduced availability of the CO2 allowances. Since the introduction of Phase 4 in 2021, we can see significant reduction in the availability of CO2 allowances in the cement industry, which is also represented graphically in the chart. This really puts a lot of pressure on cement producers to focus on sustainable solutions. Secondly, increasing carbon price. We have seen massive increases in the price of CO2 on the EU ETS trading scheme. Only 3 years ago, this was hovering around 20 euros per CO2 tonne, and today the price is around 90 euros per CO2 tonne, which is an increase of more than 400%. In the centre of the slide, we just consider social responsibility. So this is really ensuring that we leave the world in a safer place for our future generations, focusing on air quality and the overall effects of global warming. And then last but not least, the corporate or stakeholder responsibility. Sustainability ratings are a key focus point as they provide transparency to customers and investors, ensuring companies are taking action to be accountable and adapt to a sustainable economy. We see a lot more companies now using this to demonstrate they are actively reducing their carbon footprint. Brand equity is also important due to the commercial value it comes from the consumer perception of the brand name. To improve brand equity, companies are making sure investors, employees, and customers are satisfied with the economic, social, and environmental outcomes. Then we come to the opportunity to drive innovation with the introduction of new cements, coming largely from the reduction in clinker. As we all know, one of the largest contributors to CO2 emissions in the construction industry. On the bottom right-hand side of the slide, you can see a graph showing the commitment to reduce clinker in the cement industry by approximately 10%, from 2019 going down to 2030 to approximately 70%. So as a natural consequence of all of these actions to reduce CO2 footprint, there is a very significant added value benefit of reducing costs and improving the overall profitability for the company. We will cover later on in the presentation how Saint-Gobain Construction Chemicals can support cement producers to reduce carbon footprint and also generate savings as a result. On the next slide, you will see most of our product families for the cement additive portfolio, which contribute to a lower carbon footprint, resulting in cost savings, whether it be our grinding aids, which can provide efficiencies in the grinding process, For example, increasing the tons of cement produced per hour and reducing the overall energy consumption, or our activators, which enable clinker reduction or use of alternative fuels whilst maintaining the cement performances. Our new, innovative, next-generation activators can be tailor-made and adapted to suit specific cement producers' needs. These chemical activators can provide significantly higher clinker substitution, thus providing higher level of CO2 reduction as well. In some cases, this is up to 10% CO2 reduction, and in other cases, even more. On the next slide, we see the areas that the next generation activators can help cement producers to drive innovation by enabling the introduction of new cement types. For example, being able to convert from an OPC cement to a CEM2A or introduce a CEM2C. By using the next generation activators, we are able to maintain the strength performances and quality at the same time reducing CO2 and managing the costs. Separately, we can also enable use of low-cost alternative fuels versus traditional methods such as coal, oil, or gas. This really represents a cost-effective way of avoiding potential negative quality impacts that may occur from using alternative fuels and waste materials in the cement manufacturing processes. Lastly, we are able to make live adjustments to SCM content and subsequent impact to the quality. This can be done immediately by adjusting the dosage of the current activator, or alternatively, can be managed with compositional adjustments with the support from our experts in our labs. So this is really exciting, the impact that we can see in terms of CO2 reduction, introducing new cements, reducing costs, and improving the quality of the cement with our new next generation activators. I'll hand over now to Caroline, who will share more details on the mechanisms of the activators in cement.
Thank you, Pooja. The chemicals used in activators increase and accelerate the hydration of specific clinker and SCM phase. On the second picture, you could see examples of the influence of chemicals on the total heat flow released by a cement paste over the first hours of hydration. The chemical one significantly increases the main peak intensity linked to the silicate phase hydration, leading to the CSH precipitation. And on the other hand, the chemical 2 mainly influences the second peak, corresponding to the sulfate depletion point when the calcium aluminate hydration and heterogate precipitation are faster. The combination of both chemicals allow to benefit from a synergic effect. Indeed, the resulting performance is higher than the addition of the two product contributions. But activators don't only influence the hydration rates, they also influence the morphology of the transitory and the final hydrates. For instance, intragate needle crystals are generally more numerous and smaller, and the CSH network is denser. A denser hydrate network decreases the porosity at the mortar and concrete level. Consequently, the mechanical strength are enhanced. The mechanism shown focused on the clinker phases, but activators play on some SCM phases in similar way. Indeed, we can assume that fly ash, being a porous material, will also actively participate to the matrix densification if its hydration process is enhanced. The task of additive suppliers, like Saint-Gobain, is to determine the optimum component combinations, including the possible synergic effect between the components to meet the required performance on a given cement. In addition to a range of high-performance products, Saint-Gobain benefits from the methodology developed by our teams for product recommendation. The methodology applied depends on the context and the technical challenges. First, digital applications have been developed to get an instantly product recommendation, considering cement composition, process, and technical requirements. These tools also allow to estimate the environmental and economical savings from several parameters like energy consumption, cost, or the potential clinker substitution rates. The performance of a product selection can be evaluated at the laboratory level on the customer material. It can also be an opportunity to customize the activator composition to reach better performances. And finally, for the most challenging cases, when the cement system is complex and when the technical targets are ambitious, a tailor-made product can be required. In this case, design of experiments are performed to determine the chemical combination, allowing to reach the best performances. The product recommendation is a part of the global support to our customers. Indeed, our field engineers are involved to support customers in their field trials, but also to propose mill audits, training, support for plant issues, and so on. Now, we are going to show you case studies to illustrate the great benefits that our next generation of activator can bring to cement producers. You'll see that these activators also allow to produce more sustainable and profitable cements. The first case study targets the replacement of a CEM1 with a CEM2AP by keeping performances. Prior laboratory trials were performed to customize the activator composition. The right graph represents the influence of the reference additives and the selected next generation activator on the paste flow over the first hours of hydration. You can see that the last product allows to better increase the intensity of the main peak, corresponding to the calcium silicate hydration, and on the second peak, corresponding to the sulfate depletion point. Consequently, an additional gain is observed on the total heat presented on the bottom right graph. It corresponds to the overall hydration. It means that our next generation activator had a higher influence on the cement hydration compared to the reference activator. So, first field trial were performed on the CEM1 by comparing the performance of a next generation activator dosed at 1000 ppm with a reference activator dosed at 500 ppm. The two-day strengths are similar between the cements, but the use of our next generation activator allowed to significantly improve the 28 days strength. Indeed, the gain is about 6 ampere. So a second field trial was performed by producing the CEM2AP with the next generation activator at 950 ppm. The use of the next generation activator allowed to maintain the performance of the CEM1 treated with a conventional additive on the 2 and the 28-day strength. In this example, the additive has offset the negative impact of the clinker substitution on the cement performance. It allowed us to save 8% of CO2 thanks to the clinker factor reduction. The second case study concerns the production of the limestone cements. In this example, the next generation activators was used at 800 ppm. It has allowed to reduce the clinker factor of a cement by 8% compared to the cement produced with a reference additive. The strengths measured on the mortar are similar at 2 days, but the 28-day strength was significantly enhanced with the next generation activator despite the significant clinker reduction factor. This benefit is also maintained at the concrete level, where the 2-day strength was still maintained, and the 4 MPa gain at the mortar level were also observed at the concrete level. We are very proud of this case study, as the use of the next generation activator has allowed to decrease the CO2 emission by 9% at the cement and the concrete carbon footprint. This saving has a real added value not only for the cement producers but also for the concrete producer. But the most important is that we were able to produce a cement with a better quality as a 28-day strength for enhanced. The last benefits for the cement producer are the cost savings. Pooja will explain you the different levels that the activators play on.
Thank you, Caroline. So, to demonstrate the savings, you can see in this example, despite having some increase in the overall cost of the next generation activator, the cement composition savings, which really are coming from clinker replacement, the lower cost of repairs and maintenance, and energy cost savings, provides a significant amount of savings, over €500,000 annually. And this is actually without even considering the potential cost avoidance of the EU ETS carbon price. In this example, we consider it at €85 per CO2 tonne, And if we include this as part of the calculation, we can achieve more than 3 million savings annually based on production of 500k tonnes of cement. Now, I must highlight that in this example, we have considered a cement plant with no CO2 allowances available. However, even if we consider a 50% CO2 allowances availability, the savings are still very significant and over 1.5 million euros annually. So I think this case study really helps to demonstrate that our next generation activators can not only reduce carbon footprint, but at the same time also help to drive the introduction of new innovative cements, improve quality, and overall contribute to cost savings. So that brings us to the end of our presentation today. In case you would like some more information about our chemical additive solutions, please feel free to contact me directly on the email address shown, or you can scan the QR code, enter your contact details and information on the link, and we'll get back to you as soon as we can. Thank you so much for your time, and I hope you enjoyed listening.
Thank you very much, both of you, for that presentation. Really well put, very, very clear, the benefits from these additives. And it's at a time when the whole industry is really looking to shift, lower the clinker factor and start bringing on the limestone cements, and then ultimately the calcined clay cements and other SCMs, which I'm sure you're looking forward to, because you can add a lot of value in that area. Calcined clay cements are not very widespread still. A lot of projects are upcoming. There's a couple in France particularly that are very interesting, and we've covered those in our magazine. And West Africa is also bringing on new calcined clay capacity. But I don't think the rest of the industry has really got to that critical point yet. So in general, your products, where do you see them used the most? I mean, your chemical additives are used
chemical additives are very vastly present in the chemical.
Do you see a lot of demand coming on for the LC3 or calcined clay cements? Is there anything you can talk about the impacts of the additives, maybe Caroline, in terms of water demand and the quality of the cements and concretes that are produced, and whether grinding aids can help?
Yes, sure. Calcined clay generally requires activation on the lay strength, but they also have a particularity to have high water demand. So it's a characteristic we need to consider when we customize products for a customer. Mm-hmm. So it depends on the quality of the clay, of impurities, fineness, and so on, and also the overall cement composition. You say customizing the chemical additives. Is that the case for every plant that will use your additives? Is it a process of customizing in each time, or are there standard products that are quite widely used? Yes, because actually there are no universal additives allowing to treat all cement with the highest performance. As we explained, the product selection depends on different parameters like cement composition, technical requirements. So we gave the example of cement with calcined clay, but the requirements could be different, for instance, for a slag cement, because in this case, there are less issues with the water demand, and in this case, generally, the requirements are more focused on the early age. So it's a real case-by-case approach when we need to address a product to a customer. We check all the parameters concerning the cement composition, but also all information from the process and what are the real targets of the customer to design the best activator as possible to avoid over quality, but by keeping in mind the real technical requirements.
And there's a question here asking about the kind of chemical composition of the activators themselves. Can you talk a little bit about that?
The composition really depends on the case. So what I can say is our next generation activator range we developed involve a part of new components and also new combination. So it's not only a question of formulation, but the way we address the product recommendation.
Yeah, sure. Okay. Well, thank you very much. Very inspiring presentation. Some great figures there. I mean, 8% reduction in clinker possible, and also the way that you explain the savings to concrete producers, which is another insight which I think we'll find very useful. Please, well, we have the presentation. It will be distributed after to all the people who've registered, over 1,000 for this webinar. Thank you very much for your presentation today.
Thank you.
Thank you, Tom.
That's great. So there we go. That's the third one, and we're going to move now swiftly on to our last presentation. I'm very patiently waiting for us, Mohammed Magdeldin, or Maj, I believe I should call you. Welcome to the webinar, and we're really interested to hear what you've got to say about carbon capture. If you'd like to share your slides now. Mohammed is Head of Development Activities for Sumitomo SIH-FW's Carbon Capture Solutions, working on a number of global decarbonisation projects with key industrial partners to effectively remove CO2 in a cost-efficient manner. Maj believes that the accelerated deployment of bioenergy with carbon capture, storage and utilisation is key to reaching carbon neutrality and net zero emissions globally. He is a process and chemical engineer by practice, with a master's in energy engineering and renewables from TU Berlin, Germany, and a PhD from Aalto University in Finland on valorizing bio-based residues towards synthetic hydrogen carriers. So we're going to have a very interesting presentation here on carbon capture, such an important subject, one that's evolving very quickly. Over to you, Maj.
Thank you very much, Thomas. Very happy to be here, and I've been a keen listener to previous webinars, and very happy to take part now as a speaker and share some of our insights on carbon capture solutions from Sumitomo SHI-FW. My name is Mohammed Magdeldin, or please call me Magd. As Thomas mentioned, I'm responsible for global business development of our carbon capture solutions. And today, I'll be talking about how cement operators can maximize revenue streams and project feasibilities while at the same time capturing CO2 emissions. Before going a little bit into the technology itself, I thought maybe to brief the audience on the company, Sumitomo SHI-FW. We like to be called as where the name SFW comes from. So we are part of Sumitomo Heavy Industries, based in Japan, headquarters in Tokyo. But I am actually based in Finland, where the global business development for carbon capture and also our technology center in the city of Varkaus is located. As a company, we have roots in Alstrom, Finland, where the first circulating fluidized bed pilot was demonstrated. I'll speak a little bit more on the technology, but also in the former Foster Wheeler in North America. As I touched on, we have over 100 years of delivering sustainable energy solutions that including as well flue gas cleaning. We remain the market leader in circulating fluidized beds. Specifically, we've delivered over the years more than 700 actually solid fuel boiler plants. And as part of our responsibility within the energy transition, increasingly in the last 10 years, our focus has been almost exclusively on biomass and waste-fired power plants. We hold a 40% market share in that. But as part of our responsibility to contribute solutions towards the energy transition and provide decarbonization and climate mitigation technologies and platforms for efficient production of energy and materials, we've diversified our portfolio. So energy generation is of course referencing our key markets previously, but more increasingly the topic of the day, carbon capture. Well, I speak a little bit more in detail on the different solutions we offer there. But along with that, we provide lifetime services for our strategic partners and customers. We provide solutions for waste to value, which includes the conversion of solid waste into what we call clean syngas intended for the production of biofuels and chemicals. And finally, we also deliver energy storage with a specific focus on long duration energy storage applications. This is a global view of our existing references. You'll see quite widespread out with a specific focus in North America, Europe, and in Asia. You see different color codings. Those represent the different solutions. I would just bring everyone's attention to the technology platform that we'll be talking about today, which is the CFB and the blue dotted power points. So for those who are not that familiar with the technology, what is a CFB? It is short for circulating fluidized bed technology. And it is utilized by SFW as the platform for our new technologies, thinking here carbon capture and also gasification, mainly to the inherent advantages of a CFB. Just to name a few, it is quite a flexible technology in terms of the types of fuels that can be utilized. You see on the figure here on the left, all the way from fossil solids all the way to recycled waste fuels. And including, of course, biomass and agro. It's important to note also that there's opportunities for co-firing, where liquid and gaseous fuels can be applied. And an inherent reason for this fuel flexibility is actually, as you see in the figure here, the mixing of solids and gas streams within the circulating fluidized bed. So the name comes from that the solids within the unit are continuously recirculated within the unit to ensure efficient control of the reactions taking place. And they come in contact with mixing with the gaseous streams that are fed into the system, either air or in the technology today, CO2 and water vapor. But also another advantages of a CFB, beside the fuel flexibility and an efficient mixing and control of chemicals, is the simple emission control system. So it's well known CFBs compared to alternative technologies carry very low NOx, mainly due to not just the control of the reactions, but the control of the adiabatic conditions and specific temperature levels within the unit. Also, there are ways to capture sulfur within the furnace itself, and as well producing very low level of impurities. All of this adds to the key feature of a circulating fluidized bed, which is the high reliability and low maintenance needed for the technology. And our development over the years culminated in us delivering the largest biomass CFD power plant, 300 megawatt electric in the UK. But we have not, over the years, not only looked at the combustion systems within CFDs, we like to think that we were one of the early movers when it comes to carbon capture. Already in the early 2010s, we demonstrated how to integrate energy generation and carbon capture within the circulating fluidized bed, what is known as an oxy-fuel CFD. So you'll see here the images on the left of our demonstration project in Ponferrada, Spain. It's a 30 megawatt thermal oxy-fuel power plant. This demonstration project was going for a long period from 2009 to 2017, where the full value chain CO2 was captured from the CFD and finally injected in a saline aquifer. Typically with carbon capture, you have two approaches. Either you capture the CO2 within the energy generation or the combustion process, or you capture the CO2 as a post-combustion. So after the CO2 is released in the flue gases. And the figure on the right represents our calcium looping technology, which is a post-combustion capture. You'll see it is connected to the flue gas coming from an existing power plant. And the flue gas is subjected to a dual fluidized bed system where CO2 is captured efficiently and released in a concentrated form. The plant was demonstrated already in La Pareda, Spain since 2012 and has been operated for thousands of hours with quite a high capture efficiency. But maybe to bring a little bit into the focus of today, so what are the carbon removal methods that we have available today? And I touched on that briefly earlier, that as part of our strategic focus in the energy transition, we exclusively look at what we call BECCS or BECO, which is bioenergy with carbon capture and storage or utilization. And you'll see on the figure on the left here, where we look at circular economy applications, where the carbon dioxide is either neutral or negative. Neutral, of course, if it's part of a circular application where CO2 is recycled back into products consumed and returned, or negative if it's sent for permanent storage and removal. And as part of the development today, what we like to approach with our carbon capture solutions is to ensure that they bring the most added value. And as such, I briefly touched on it earlier, that we have different solutions for different applications. So we have the SFW Oxy Plus, which represents a solution for oxy-fuel power plants, carbon negative heat and power. We have the technology of the day, SFW Cal Plus, which is based on calcium looping. So as using a natural solvent, more or less calcium, to capture and release the CO2. And there's many added value from calcium looping that we see that the solution fits perfectly towards the decarbonization and emission reductions, for example, in the cement and metallurgical plants. And finally, we have our third solution, SFW HPC, hot potassium carbonate, which we are partnering with Capsule Technologies on delivering modularized concepts for biomass and waste to energy plants. And this is based on a liquid solvent, a benign and efficient liquid solvent for carbon removal purposes. And if we take a look at on where we see the role of our carbon capture, utilization, and storage solutions. So you'll see in the center here our oxy-fuel or calcium looping solutions, and we really see them as a bridge or a link that connects three key pillars of the decarbonization and energy transition. So the first is the increased penetration of variable renewable energy, possibly utilized to produce green hydrogen applications. Typically, these green hydrogen applications would have oxygen as an available byproduct. That oxygen will be used in our oxy-fuel or calcium looping system. Both of the solutions look at circular applications where we utilize sustainable bioresidues and non-recyclable wastes and direct those to produce biogenic CO2. Of course, specifically with gas by capturing CO2 emissions that are initiated from this addition as well available. We look at decarbonizing or removing. So it's gone briefly that the flue gas is generated with CO2 in it. The flue gas comes into contact with the first unit, which captures the CO2 to form calcium carbonate via the reaction shown. The calcium carbonate is then directed to a calciner, which operates as an oxy-fuel calciner to produce concentrated CO2 and recirculate back the calcium oxide, hence the looping aspect in the system. So this is a closed loop where calcium is used to capture and release the CO2. A bit of a closer look on the block and what it entails. You'll see here a schematic of a fluidized bed where there is an exchangeable solid streams between both the carbonation step and the calcination step. And really, when it comes to calcium looping, it is a multi-product technology where we're not only capturing the CO2, but we're also, by this efficient cycling of solids, we generate additional revenue streams in the form of potentially power, heat available from the system. Depending on the specific case and the location, the fuel can allow for additional waste gate fees. Of course, when capturing CO2, gives an opportunity for carbon removal credits. And as part of this is an oxy-fuel calciner, the need for oxygen can always come from a plant that's either producing nitrogen or hydrogen as an additional revenue or resource stream. So many revenue streams. But if we come with a little bit of focus on the cement industry, with the cycling of the solids, there is an opportunity to extract a calcium oxide from the system, what is known as a purge from the carbon capture. And this can act as an SCM in the cement industry. So you see many opportunities that can be created for an existing industrial asset. So this is just an image of the existing pilot that has been operating for more than 10 years at the moment, with extensive experience and under different operating conditions. And just to share, recently, last year, we were awarded 2 demonstration projects. First is called CAL by 2030, and it's intended to deliver and showcase integrated calcium looping at different industry relevant conditions. And here looking at cement applications, iron and steel, and bio, CHP, and waste energy. And maybe just to highlight the close collaboration that we're working with Thomas Cement on looking at integrating calcium looping at their Karlsdorf plant in Germany. But we also have another project called Hercules, which was awarded, and this looks at the full CCUS value chain. So the calcium looping is applied in a waste-to-energy plant, but however, the purge, the calcium oxide produced from the calcium looping, will be tested for in cement production. And I'd like to showcase results from a feasibility study that we conducted on looking at applying calcium looping to an existing cement plant. But before jumping into that, just want to bring into focus why carbon capture is a key element in the contribution to net zero. And you'll see that the GCCA, in listing out the different contributions to reaching net zero, the largest impact can be realized with carbon removal and CCUS in specific. But if we go at the cement plant case, and this is a result of a feasibility, as I mentioned, that we looked at capturing 400,000 tons per annum of CO2 from an existing stack. We looked at utilizing RDF or waste-derived fuels in our calcium looping system, and we captured over 95% of the CO2 that's generated in the plant while producing net power of 28 megawatts for the plant and additional calcined lime of around 80,000 tons per annum. But in terms of carbon removal, and as I mentioned earlier, due to the biogenic fraction of fuel applied in the calcium looping, the overall performance of the plant led to a net carbon negative of around 178,000 tons per annum. And that was a key advantage of the system, the net negativity aspect. But also because of the electricity production that is in place, CO2 that's associated with scope 2 emissions, so grid emissions, were avoided for up to 77,000 tons per annum. And maybe if we take a look closer on one of these potential revenue streams, for example, the additional power production in the cement plant. So this is kind of a breakdown of the gross power that can be produced in the plant and the different usages. So you'll see that the calcium looping itself does not use a significant amount of power. Typically, you have consumption in the oxygen production. This is traditionally by an air separation unit, but in thinking of green hydrogen production and the fact that oxygen can be procured from co-located green hydrogen plants, so this is a potential saving. CPU here represents the CO2 compression and liquefaction that would be needed to bring the CO2 through transport or pipeline conditions that are typically as part of the value chain requirements. But all in all, even in considering all of the different power consumers, as you see, we still have net production of 28 megawatts of power for both the cement plant's own consumption plus opportunity to be a net producer and exporter of power. And of course, we try to allocate the different opportunities within the feasibility and economic evaluation. So of course, this is really dependent on the case study, the specific cement plan, but also the variable business case. So which one of the potential revenue streams are utilized? So some assumptions are listed here on the right for the purpose, but just to showcase that in terms of capturing CO2 for this specific case, we reach around 52 euros per ton of captured CO2. And when thinking of typical transport and storage from Central Europe to one of the potential storage locations in Northern Europe, that brings up to a total cost of capture and storage of 97 euros per ton. Of course, it's important to keep this number in the context of what was mentioned by the earlier speaker, that current ETS pricing is higher than 100 euros per ton. And it's also important to take into account the impact of CBAM regulation in Europe, where the reporting period will already start in October this year and implementation to come in 2 years' time. So we see definitely an opportunity and for calcium looping and SFW Cal Plus to provide a net positive project feasibility for cement operators. And just to conclude, we believe that we are the right partner for carbon capture for cement operators. We provide a balanced technology portfolio, which comes along with a global project delivery capabilities for a wide range of industries. Our SFW Cal Plus solution is a multi-product solution with specific advantages for hard-to-abate sectors, for example, like cement. The solution enables operators to build a flexible business case for carbon capture, so not only looking at the removal of emission, but also maximizing byproducts and revenue streams, just to mention a few: calcined lime, heat and power, waste gate fees, and others. And all in all, we conclude that SFW Cal Plus offers operators a resource-efficient commercial roadmap for carbon neutrality and circular economy applications, already targeting these reductions in the current decade by 2030. So thank you very much for tuning in to my presentation. If any further info, please check out our website or reach out to me directly. Also, we'll be joining in the cemtech event in Istanbul, which I'm really looking forward to, and hopefully I'll meet more in person as well. Thank you very much.
Thank you very much, Magda. That's really a fascinating presentation. A lot of new technology there for those of us in the cement industry. Very interesting numbers as well that you've given. There was a report released very recently by Bureau highlighting the high cost of energy for carbon capture systems. And as your chart show it's not just the capture cost, there's also the transportation and then the storage. So although you highlight 52 euros a ton for the capture, that can actually rise to around 120 when you factor in the next two components. So there is a lot of moving parts for people to consider. But just focusing on the technology, you highlighted the calcium looping as the principal carbon capture technology for cement. Instead of oxyfuel, or are you also developing oxyfuel for the cement industry?
Well, calcium looping is in a sense a form of oxyfuel, but a post-combustion oxyfuel, because we have, as mentioned, you have the carbonator and you have the calciner, which operates as an oxyfuel calciner. But to answer your question, I believe, Thomas, you're referring to an oxyfuel in a rotary kiln. And no, our focus is on the fluidized bed applications. Yeah.
Okay, which is transferring technology that you've used for a long time in other sectors.
And exactly, and that also addresses the commercial roadmap aspect. So when we're always asked, so when can the technology be introduced to the market, we do tap into our knowledge and experience of delivering, as I mentioned, many CFBs for wide applications of fuels, including wide, let's say, chemistry that is involved, a lot of which is similar to what is applied in the cement industry and applied in the calcium looping for carbon capture.
Sure. In terms of timeline and everything, you, as I understand it, you have two projects now specifically geared for the cement industry. One of them, the Karlsdorf plant, where you're integrating the calcium looping, the CAL by 2030 system. And that's going to come on. What kind of timeline are you expecting for that project? And I guess it's 2030. Is that the main sort of target date for having kind of commercial availability of this technology?
That's a really excellent question, because I'd like to highlight what we're doing in the CAL by 2030 project is the integrated calcium looping. So there's two configurations. So one is called the tail end, which is connected downstream of the cement plant. And one is the integrated, which, for example, the calciner can replace one of the pre-calciners steps in the existing plant.
Yeah.
So the integrated option, that's what we're demonstrating at the moment, and we're looking to bring it to the market 2030s. But at the moment, we're also developing this tail end configuration, which we are targeting the first commercial plant already by 2027, 2028.
Right. So that's a simpler process. Like you say, it's downstream of the cement plant. It's taking the flue gas. And can you give us an idea of what that involves in terms of space and footprint and the practicalities of installing a system in a cement plant?
That's something that we work with our partners in our, let's say, feasibility or pre-feed efforts, because of course we look at the existing site, the available locations, and there is room for layout optimization where we ensure the different components are located optimally within the plant and within the available location for installing a carbon capture plant.
Okay. There's a few questions on the Q&A. One of them was, are you exploring utilizing existing cement plant calciners as the stripper in your process? But you've just answered that. That's the integration that you're pursuing. So good question, and
exactly.
That's been dealt with. There's a couple of questions just asking for ballpark figures, capex figures for these projects. Is anything available? Is there any indication you can give?
We can look at that for a specific site, as I mentioned, as part of a feasibility or pre-feed. But I just showed now the cost of capture, which gives an indicator. There was breaking down the capex, opex,
yeah,
and gives a certain indicator of order of magnitude. But again, I would definitely highlight that we understand that there is certain design optimizations that we do from one site to another. And of course, that has an impact on the capex aspects as well.
And I mean, generally speaking, there are different processes, different carbon capture processes out in the market. What is it that distinguishes or is a strength in your system?
I think the added value, as we touched on, one misconception about carbon capture, but I think it was actually highlighted in one of the earlier presentations, that it's an additional system, an additional cost to the existing plant. What calcium looping presents is an opportunity rather than an additional cost. So an opportunity to generate these additional revenue streams, an opportunity. Actually, I touched briefly on this purge, calcined lime purge. In that specific case that we looked at, it gave an opportunity for the plant to either increase production by 25% or reduce limestone consumption in the kiln by 25%. So there's a lot of opportunities that can be created with calcium looping compared to, let's say, typical solvent capture systems, which perform only the capture purpose.
Yeah, exactly. Really interesting. We will follow this very carefully in International Cement Review and then future cemtechs. But for now, thank you very much for that presentation. The first time we've really had that in one of our webinars. We look forward to more. So thank you very much, Magda from Sumitomo, and thanks to all our speakers, to Chryso GCP as well, and to Inform and to FCT Combustion. It's been quite a broad series of presentations. So well done, everyone, for staying with it. I'm sure everyone is coming from different parts of the business, but hopefully that's put together a good picture of some of the really important decarbonisation solutions available for the cement industry. So thanks again to all our speakers. We look forward to seeing you soon, hopefully as soon as next month, when we'll be out in Istanbul. So there's still time to get the early bird tickets. I think this week they're still available. Then they'll be the price will go up to the full rate. So take a look now online, cemtech.com/Europe 2023. Thank you very much. We're going to be back next month with our webinar on energy efficiency. But until the next time, thanks for your attention and have a good day or evening, wherever you are. Thank you very much.
Recording stopped.